Hello again. So let me talk a little bit about time value of money, or TVM. TVM stands for time value of money. It's a way of calculating some formulas that we use in finance and in evaluating investments to determine how we could use it in planning. We can use it, for instance, if you want to be able to buy a Lamborghini in 10 years, and you're able to find an investment or a savings account or an account that'll pay you a regular interest rate for the next 5 years, how much do you need to start with to be able to have enough to buy a Lamborghini in 5 years? And how much is that? How much do you need to start with to get that end result? You start off with $100 and an IRA, in a CD, and the CD is a 5-year CD, maybe, or a year-long CD. How much you're going to get when it matures in a year? Those are called yields and returns. So how do we determine that? We can do that ourselves. We don't have to go to a financial analyst or a financial planner to get that information. We can do those calculations ourselves. And that's what we use in finance. We talk about TVM. So time value of money. And to do a time value of money calculation, or we look at the formulae for time value of money, there's several that answers these questions. So the questions are, the parts of time value of money are, we're looking at present value, future value, and we need an interest rate, the term, and the frequency. Present value is, what is the value of the investment today? Future value is, what is that value of the investment going to be as it grows or as it compounds? It's called compounding when we go from the present to the future. We call that compounding. And that's the compound interest, interest on top of interest. So we can keep asking and recalculating the interest rate, which will be not a simple interest, we're talking about compound interest. If we're going in the other direction, we want to know what the present value is, but we know what the future value, that's called discounting. So it's a discount when we go backwards in time. It's a compounding when we go forwards in time. We're going to focus on discounting, which is how finance, whether it's corporate finance or it's investment valuation, we think about it in present value, and I'll explain that in a second. So we're constantly discounting those returns. The interest rate, again, is always stated in an annual rate. This is my formula talking about nominal interest rates. In another video, I'll talk about what's the difference between nominal and real, which is anticipating or incorporating inflation in our calculations for return. But we're going to just use the little i for as a nominal or just a stated rate. N is the term, or how many years long this investment is. Is it 10 years, 5 years, 2 years, 6 months, whatever. The frequency is how often are we compounding it per year. Are we counting our interest monthly? That's 12 times. That's your freak of 12. Are we doing it quarterly? That's 4 times a year. That means your freak is 4. Are we doing it semi-annually, daily? And those are different frequencies. It will result in, because of the magic of compounding, the amount in a 1 year's time, even, depending on the frequency of how often you're calculating and recalculating interest, on top of interest, on top of interest, the more often you do, the more interest you're actually going to receive at the end. So you'll have a higher return on the money if the frequency is higher. And it's very important when we talk about loans as a borrower, or, again, as a saver, what your investment is. When you're saving, you're buying an investment, whether it's a bond or a stock. How do you value that in the future? Well, we can't really say. We're talking about apples and oranges if we're talking about whether $100 is more valuable today or in 5 years or 2 years. What's that mean? Well, partly, as I said, we have inflation, which is the erosion of the purchasing power of money. But in addition to that, we also have what is the value of that future investment today. So we discount everything so we can compare the apples to apples because these apples are only relevant today. An apple today keeps the doctor away, but if you keep that doctor away, that's not going to make any difference for your investment. You need to know what that today's apple is. So we're going to be talking more and more in these videos about future discounting our values down to today to better understand it because we're looking at today's dollar and can compare now apples to apples versus apples to oranges. So if we're looking at a single investment, one-time cash flow, and outward cash flow into a loan, a simple loan, where it's a single payment or a simple interest loan or a simple interest investment, where there's no additional payments except your initial investment and then the return at the end, your initial return of your initial investment plus the appreciation of it, we have to discount that future value. If you're expecting to have $200, what does that mean today at 10%? That's what this formula is going to tell us. So this formula tells us PV, which is the present value. We know what the future value is. We're looking for the present value. So you take the future value and divide that 1 plus the interest rate. And the interest rate is noted in decimals. So it's 1 plus the interest rate raised to the term. So that will tell us, and the future value divided by that will actually, that helps us understand that the relationship between the present value and the future value is that present value will always be smaller. That's why it's called a discount. It's discounted from that future value. And the future value is divided by this factor here. I call that the future value factor, interest factor. I call that, this part right here is the future value interest factor. If you divide future value by the factor, you'll get that present value. I mentioned the freak, and I would like to talk a little bit more about what that freak really means. We have to incorporate that into the formula if we're going to make sure that we have a proper output that we're looking for. So if you're going to have a freak, and I'm going to star that so we know we're talking about freak, what the freak will actually do is the frequency, we take the term. If we're going to do this, then we actually take this term and we have to multiply the term by the freak. And we have to do something with the interest rate. The interest is divided by the freak. So if there's a frequency that is outside of 1, because 1, if you do this with 1, it doesn't change anything. But if we have a frequency that's different than 1, that means it's more than once a year that the interest is calculated, and compounded, then we have to, this is going to make an impact on this, meaning the bottom, the interest factor here, this bottom part. Now, if we're looking, if the term is stated in years, and usually this is stated in years, but if you're compounding more often in that year, then you have to multiply the year by the number of compounding periods. So if you're compounding quarterly and it's a 5-year investment, then you're compounding 20 times. If your investment is 10 years and it's compounded monthly, then you have 120 compounding periods. So that means that N will have to be 120, even though the term here is 10. That's because that frequency becomes monthly or 12 times. Now, if we look at the interest rate, I've said before, interest rates are always noted or delineated in annual, as an annualized figure. And if it's an annualized figure, then that if it's more often, then you are really taking that annualized figure and shrinking it or cutting it into smaller bits. If it's 4 times, then that annual figure is really you're taking that a quarter of that interest and charging interest there, then another quarter in the next quarter, and you're compounding that quarter of that interest rate every time, or making a 1/12 of it if you're doing monthly, or half of it if you're doing every 6 months or semi-annually. So we divide the interest rate by the frequency will tell us, not tell us, but will show that we have an incremental increase in the interest on interest calculation, monthly, whatever, based on the frequency. So for example, if the interest rate is 12% and the interest is calculated compounding monthly, then you're really looking at a 1% per month, or 12% per year. 1% per month, but then the next month you were taking that principal amount plus the 1% you calculated the first month, and you're adding another 1% on top of that. That's that compounding. Versus doing 12% all the way through, you notice that it's because you're compounding on a smaller interval. The interval being 1 month versus 12 months or 1 year, that changes drastically. In some cases, it could change drastically your total amount of the future value at the end of the term. So we'll start off with this one, and we'll go to other applications in a little bit. Welcome back to another video. In this video, I'm going to quickly discuss and talk about the difference between real and nominal. In economics, we talk about real and nominal values, in that the nominal value is the value of something that's in today's dollars, or something that is in today's value, where real value is a comparison of products between 2 different time periods. Also, it's the net. In this case, when we talk about real versus nominal interest rates, it's the net amount of interest that you will be getting free of inflation. So we're talking about real versus nominal rates. And for my formula, which generally is similar to many formulas out there that we're going to talk about, or this expression, is that we're going to use I for what's called the nominal value, or the known value. Now, know that nominal values are always listed in an annual rate unless specifically and expressly stated otherwise. Nominal rate, interest rates are listed as an annualized rate. So you'd have to break it down if you're talking about quarters, or like I said about, or talk about in TVM and time value of money, we talk about the frequency. If it's more often than once a year, then we have to incorporate that and manipulate that value, that nominal interest rate. But when we also talk about nominal interest rates, we have to consider that that's the stated or posted rate. And that's not the rate that we're looking for necessarily. That's not what we're anticipating or expecting. Then pi is usually denoted as inflation, or the rate of inflation, the rate of the change in price levels over time. In any particular time, and it's annualized also. That's another interest rate that's annualized, but that's a rate that is going to affect your investments, affect your return, because much of that money is going to degrade, because inflation is the erosion of the purchasing power of money. We all know that a dollar is a dollar, but if we compare a dollar from today then to a dollar 10 years ago, that money, that dollar doesn't pay for what it, or you can't buy the same thing you could buy 10 years ago with that same dollar. It's all because of inflation. With price levels increasing, that change in price levels and in ascending price levels is inflation. A change in descending price levels is deflation, which has occurred in history too. But when we look at the rate of return, we have to consider what we're anticipating, what the inflation is, because that's going to reduce the actual dollar or actual money or the return that we're getting from our investments. So And what comes out of that is what the little r is real. And that's the real value of that money. What's the real value of that return when we calculate it out? So it looks kind of like this. How do you get the real interest rate is we take the nominal interest rate minus inflation. In this case, we're talking, this formula right here, we're talking about expected. That's that superscript E is referring to an expectation of inflation, and so that's the prediction we're having, a forecast of what inflation is going to be in the future. And we call that the ex ante rate because it's an anticipatory and it's including the expectation of inflation in the future. And it is really important to have that ex ante rate when you're looking at an investment that's long term. You want to consider that in long term, that the value of that money when you take it out in the future, that future value of that money is not the same as the present value of the money today, because it's the real value versus the nominal value. It could be an increase, and we'll be all excited when we put an investment at 2%. Oh, yay, we're going to have more money in the future. Well, if inflation's 3 or 4%, then we're actually looking at less money than we started off with, not more, when we incorporate that inflation and we look at the real interest rate. So if we're talking about expected interest rate, the expectation, which is also almost a self-fulfilling prophecy. If you expect inflation to go up, then businesses tend to increase their prices ex ante or in anticipation of higher prices or higher cost to them. Then their prices follow all the way through the industry, and then the whole market has increased in a self-fulfilling prophecy that there's going to be inflation. I think there's going to be inflation, so I'm going to raise my price. My price is somebody else's cost, and so on, that domino effect. So expected inflation can also, the expectation of inflation can bring about that level of inflation. But it's an inflation that we have, it's also a necessary evil we'll always have. So how do we combat that inflation of rising rising prices and changing in price levels on an aggregate level, where inflation is on an aggregate or a macro level. So when we're thinking about an anticipatory increase or an expected increase in inflation, and we adjust our nominal rate or the nominal return that we're expecting to the real, that's what we call more of an ex ante rate, because it's adjusting for the expected level. But if we settle down and find out that what's the real, and it's less than our expectation, then our real interest rate will actually be higher. And since the real interest rate will be higher, then our ex post, which is actual versus expected inflation, the rate of return will be higher, so our real interest rate will be higher in the future. So that's a little thing about real versus nominal interest rates. It stems from the economic concept of real versus nominal values. So we have to anticipate, if we anticipate inflation, then we must account for it in our calculations of return.
Three, two, one. Welcome back to another video. In this one, we're going to talk a little bit about bond valuation and knowing how to know about what the value of a bond is. And again, like I said in a previous video, we're talking about time value of money, and we're determining here what is that present value, or what is the value of that today, or discounted to today, so we can look at it with today's nominal dollars. We're looking at a dollar to dollar today versus today's dollar and a future dollar, which doesn't make any sense, only because we're talking about the value of two different types of dollars. We're talking about nominal value today and nominal value in the future. Now, the best way to value anything that has a investment that has a long term, we need to know what is that value if we had it today. If we're looking at $1,000 5 years, what does that mean today? $1,000 in 5 years, we can't tell with the differences in interest rates and a difference in rate of returns and real rate of returns and real interest rates. When you talk about inflation, then we have changed the value of that money. And that money may not be as valuable in a future in 5 years than it is today. But what does that really mean today? What is that value of that investment today? Then we can look at it and compare it. In finance, we do that all the time. We need to know what that means today in anticipation of what's going to happen or expectations of what's going to happen in the future. So we talked about a simple loan. I will put it in air quotes, simple loan. It's a compounded loan, not simple interest, but compounding interest. Using the formula right here in green, if we want to know what the present value of a future investment is, we know what's going to be in the future. We need to know some of the parts. We need to know whether it's a future value we're looking for, the present value we're looking for. We need to know interest rate. We need to know the term and the frequency of how often that the compounding periods in a particular year. And N is designated in a year. The term is in a year. So the frequency is multiplied by the year, number of years, and the interest rate is divided, the nominal interest rate is divided by that frequency, or the freak. If it's 6 months, that's twice a year. That freak is twice the N and half the I, for instance. And that's how many periods were. Instead of 5 years, it's actually 10 periods of compounding versus 5 periods if it's annual. So we're going to look at now a bond. Now a bond is a unique piece in this investment of a loan. It's not just a simple single payment loan, which interest is accrued, and then the final payment is principal plus interest, which is that compounding, and that's a single pay, meaning we put it in or we loan it out today, and then we get the return of the nominal interest compounded plus the principal we originally got. What is that value today? So we know what our expectations are in the future. So here we're going to look at a bond with a coupon. A coupon is the interest rate that is charged for the use of that money. So it is a loan. It's sort of like a reverse loan in that savers are the lenders, but there's no intermediary. There's no financial institution intermediary like a bank, where a saver would put money into a bank and the bank determines where that money goes, like I said in the previous video, and that's mitigating some of that risk. It's a risk sharing. The saver has a bit of risk. The financial institution carries some of that risk, but the risk is mitigated and shared between the savers, account holders, the depositors, and the bank, with that return to be kept by the bank and doled out to the savers in a interest rate for that savings account. So this is more of a direct lending in that savers are buying the bond directly from the borrower or the spender. In this case, it could be a corporate bond, it could be a federal or a government bond. Government bonds do have coupons. Some corporate bonds have coupons, and that face value or that nominal interest rate is what we're looking at, and how we're going to determine one. So there's two parts to a bond. There's the principal amount. When you invest that money, what that price is that you buy the bond, what is that present value of that price, and what is the present value of the cash flows, the interest payments that are made, and what are that, and then included in that is that frequency. And so that would be this formula right here. We're looking at the price of the bond, and the price of the bond, which is today's money, because we're buying it today, the sum of all of those interest payments divided by the interest rate, one plus the interest rate, the nominal interest rate, or that rate of return we're requiring, and then the future value of that bond divided by also the one plus the interest rate. So the bottom part here are very similar factors. We're talking about the future factor. But we have to take those as two separate items. There are two separate calculations we have to do. You can't just put it into one. There's an easier way And I'm going to show you that formula right now. The easy way to calculate this without going through every single one of these calculations and adding them up, I have a very simple way, and we use time value of money formulas to do that. And that is, let's follow the arrows backwards. To do the second part of this, which is the future, we know the future value of that bond, what is the present value of that bond, is the same formula we saw before. Present value equals the future value divided by 1 plus the interest rate raised to the number of years or number of calculated, of compounding periods. That we've seen in a previous video, and that's the same as we see in a single pay note or a single pay loan, where we have an invested or a borrowed amount, and that borrowed amount accrues interest over the compounding period, and then there's a return or a future value of that. What is that present value? So we can look at that, compare apples to apples. But we have to also consider the interest part or the interest payment portion, which is also a part of this too. This is the future value of the principal, but now we have to take in consideration the present value, this is the present value of the principal. Now we have to take in consideration the present value of the interest payments, which is known. So the interest payments are the same as an annuity. An annuity is an investment where there's a regular cash flow, meaning that the size of the cash flow is the same period to period, whether it's paid monthly, paid semi-annually, paid quarterly, paid annually. That also equates to the compounding, the amount that the annuity that's paid back, which is a portion of the investment, plus the final payment would be the principal plus the accrued interest not paid already in the annuity payments. So this is the same as an annuity, meaning that it's a regular annuity, meaning that the payments or that this amount here is a regular amount. So that A is equating to this I, which is the payment amount. But I had to change the name a little bit because I'm not talking about interest payment alone over here. I'm talking about the interest payment as an annuity. It's the same calculation. So what is the present value of that annuity payment, that amount? So we do this calculation here, which is slightly different. It's this, you see, this is very similar. You see this similarity here is here and here. So follow the dots, it's the same. But we're going to take 1, the number 1, minus 1 over that. So that interest factor, that present value interest factor that we talked about, that part right here is just the factor. We're going to take 1 away from that and then divide that by that interest, nominal interest amount. That right there is that annuity factor, that annuity factor that we're going to multiply the annuity by to discount the annuity from the future to the present. This one gives us that future value or the principal amount reduced or discounted to the present. This one will give us that annuity payment or that interest payment reduced down to the present. Added those together should give us what our investment should be in that bond, the price of the bond. And the price is that we should pay for it because of our whether it's an anticipated yield or the nominal rate. What are we looking for as a yield versus what we expect based on the nominal or stated annual interest rate on those bonds? Are they the same? Is it worth it? Is it worth the value? Another couple of more TVM formulas I'd like to throw out there. I think they're very cool. What if you don't know what the interest rate is? That's an interesting question. You don't know what the interest rate is. You would like to know what interest or that nominal rate of return you're getting on that investment. You know what you put into it. That's the present value. You know what the future value is. You know how long it is. You don't know what the interest rate is. Well, you can take it by taking the future value, which is a stated known amount. You know that it's $1,000, and you want to put in $100 today, and it's going to be an annual. We'll make it a simple example here. It's only $100 today, and in 5 years you want $1,000 to take out, or you loan you're going to end up having $1,000, at the end of the period. So you know it's 5 years, it compounds annually, but we don't know what the interest rate is. We can then say 1,000 would be your future value, 100 is your present value, your initial investment, and 1 over 5 would be our exponent here. And then that figure right there, minus 1, will give us a decimal, which will convert to a number, or percent, excuse me, and that will be your annual rate of return or annual interest rate that you're getting from that investment. Remember, you have to know a couple of pieces. I repeat that there's future value, present value, interest rate, term, and the frequency. And if you need to know, if you're searching for one, you need to know at least 3 of the others. Here we have future value, present value, and term, searching for the interest rate. Here we have future value, interest rate, and term, we're looking for the present value. Here we have interest rate, term, and the annuity, we're looking for the present value of that annuity. So you can use both of this one works the same, or what you were looking for. Now, here's one more. What if you want to know how long in years this investment is actually going to be? You know the interest rate, you know the future value of that investment, you know the present value or the saving amount, how much you're investing in it, but you don't know how long this will take. How long will it take? Say you want a Mercedes, and you want to know how much you have to put aside every year for Mercedes, or how much do you need to set aside once for a Mercedes. Let's do it that way, make it more simple. I want to set aside so much money. How long will it take for me to get a $50,000 Mercedes, low-end Mercedes? And I put in $1,000 today, and it's a fixed interest rate of 7%. Wishful thinking, I know, wishful thinking. In this time, in this day and age, at the time of this recording, interest rates are not that high. But let's pretend you can do this calculation easy. So you would take your future value of $50,000, your present value, which is the $1,000. You want $1,000. I'm changing it. Let's say you want to put in $1,000 in the bank that you know that's going to have a 7% annual interest rate, and it's going to have a future value of $50,000. At how long is it going to take to grow to $50,000 at an interest rate of 7%? There's a calculus proof to figure out this. I'm not going to go into it. If you wish, I can do a separate video to prove that how this works, but there's a way of doing it through calculus. Whether or not you have had it, or it's material for this class, you don't need calculus. Much of it will be calculations or arithmetic, with a little bit, as you can see, of natural log. But the natural log of the future value divided by the present value divided by the natural log of 1 plus I, which is the nominal interest rate. And that will give you the term in years, not the frequency, but the term in years. Then you can go from there and figure out what that frequency is, how often is it compounding, then you can expand on the number of terms. So that's a few things that I thought would round out our information on Chapter 3 that might help us out in taking care of the homework, and but most importantly, your understanding of how we're going to value bonds, because that's part of those financial instruments we're going to be discussing through this class. See you next time.